So thank you, Jen. Today I'm happy to be here, and I'm going to talk about something that I think is actually pretty cool, and that's building 3 different applications using one language, JavaScript. This is JS Mobile Conf, and doing so from a single code base. So more specifically, just to sort of back up, I'm talking about building native iOS applications, so apps that you can find on the iOS App Store, web apps, so apps that you find just through web browsers and URLs, and native Android apps as well that are distributed through a place like Google Play. To do so, I'm going to start by giving you a little bit of a background of the situation here. Why would you want to build apps for all 3 of these platforms? What's some of the history behind doing this and some of the approaches that are out there? But I'll spend the lion's share of our time today actually demoing 2 different projects for you. I have one that's React Native based and one that is NativeScript based, which is near and dear to me. And we'll take a look and compare and contrast these approaches, so hopefully you can get an idea of what building an app with some of these approaches to building applications look like. Now, I promised a little bit of background to start, and I'm going to start with what I think is one of the more contentious debates we've had in the tech world over the last decade or so, and that is web versus native. So if you're not familiar with this, really since the dawn of the iPhone, developers have debated whether it is better to build web applications that you access through a browser or natively installed apps for places like iOS or Android, or if we go back further to Todd's keynote, to places like BlackBerry and Windows Phone as well. Now, personally, I have a long history with this debate. I've sort of been on both sides of things. I started off as a web developer. I spent a lot of time on the web. So I've written lots of articles defending the web approach, advocating for the web and the web approach to doing things. I became a developer advocate here at Progress, so I spent a lot of time with developers building native applications. I've worked a lot with them through projects like NativeScript, and I've come to see the benefits of working in a native world as well, and some of the real-world advantages it can have for developers and companies. And in fact, if you look up enough of my writings on this topic, I've went back and forth on this issue so many times that I'm pretty sure I'm now legally a candidate for the midterm elections, just because I change my stances on this all over the place. But as I've spent time on this, and as I've talked to a bunch of people like you and been involved with this conversation, more and more I think that when it comes, or at least when you're dealing with situations where you're choosing between the web and native applications, that oftentimes the answer isn't one or the other, but potentially both, and building for both platforms simultaneously. And that's what I hope to prove and show to you today. And part of my background here is, as I've worked with this debate, as I talk to people that are, especially on the fringe ends of this debate, that are really huge web fans or native fanboys as well, even people on the ends of this argument tend to find a few things that they can agree with. For example, I think most people would agree that native apps just get used a lot more. There's a lot of data to support this. For example, today, something like 90% of internet time the users spend on applications rather than web apps. And if you take the internet part out of that, just because apps tend to be better at offline, I've seen studies that have shown apps get used 15 or 16 times more than web applications. So whether we like to admit it or not, a whole large chunk of users are just more accustomed to using native apps, and they're also more accustomed to looking at places like the iOS App Store or Google Play to find applications. Now, on the flip side of things, the web happens to be really great for reach. There's data to back up that if you put applications out for the web and for native apps, users are far more likely to find your web application, which makes sense because the web is not restricted in any ways. It runs on all platforms. It runs on all devices. So by its very nature, it's going to be something that more users are going to be able to find and use. So if we can agree that each platform has its own sort of unique benefits, that there's reasons to build for all platforms, then if you consider, just imagine for me hypothetically, that you're in a situation, this isn't very common, where you have unlimited resources to build applications. You have tons of staff, money keeps pouring in, you've got all this time, there's rainbows around, there's unicorns, everything's really totally rosy. In situations like that, it's hard to imagine why you wouldn't want to build for all of these platforms. Why wouldn't you want to create the best possible apps for your users on all of these platforms if these resources aren't a problem? I'll also submit as evidence here, if you just take a minute to think of 3 or 4 applications that you use a lot throughout your day-to-day life. So think about apps that you use to listen to music or watch videos or stream or get directions. There's a really good chance that those applications are already available both on the web and native applications. All of these on this list are, And actually, when I went through lists of like top 10, top 20 applications out there on the market today, they're pretty much all universally available. In fact, the only exceptions I could find were apps that are kind of 100% dependent on some sort of mobile hardware feature. So think like Snapchat, which is very dependent on a device's camera. Uber and Lyft were the other big exceptions because, again, need geolocation on the device. But other than that, most of these companies are building applications for all of these places. Now, of course, the giant caveat to what I just said is, I said if resources aren't a problem, if you're running around with tons of money, tons of developers, no deadlines. But most people, I'm guessing you in this room, your next application, I'm guessing you don't have YouTube's budget to create this application. And if you do have YouTube's budget, come chat with me afterwards and we can talk a little bit. But most developers are dealing with restrictions, timelines, deadlines, resources problems, all these sort of real-world things that get in the way of our application development. And this is what really fuels the debate. Because when you are resource constrained, you have to make decisions, you have to make cuts that you might not want to make otherwise. This situation, though, has also led to a lot of development effort, a lot of engineering effort to try to make this situation better. Essentially, try to make it easier to build for all three of these platforms. Now, there are a number of different approaches. The two that I'm going to talk about today that I think are pretty cool, sort of newer approaches for tackling this problem. One is called React Native Web, which comes out of the React Native community. And another is called NativeScript Schematics, which is something that I've been involved with, and we have some of the NativeScript team throughout this room. It's a collaboration between us and the Angular team. Now first, just to set the stage, I'm actually just curious, so I'm going to ask you all a few questions. By show of hands, how many people here are familiar with React Native, just at least a little bit? So that's, I'd say, about 2/3 of the room. Excellent. So second, similar question, how many people are at least somewhat familiar with NativeScript? Excellent. So that's probably about half or 2/3 of the room. So for those of you that are not familiar, both of these projects are ways of building iOS and Android applications using JavaScript. So you use JavaScript, but at the end of the day, you're creating actual native iOS and Android cross-platform applications. React Native is done by the Facebook team at Google. NativeScript is from the NativeScript team here at Progress. And one of the characterizing features of each of these frameworks is that you're building applications that use native user interface controls. So these aren't web apps that are just wrapped and running in a mobile device. It's actually using the built-in native controls on iOS or Android. So you get sort of the performance you'd expect from an app that you would download from a place like the App Store or Google Play. And your apps look native because they are actually using the native controls. To back up, though, the one thing about this that is interesting for our story, remember, we're talking about apps that can run on all three of these platforms, is that the markup you actually use to write your applications. So even though most of your source code is actually in JavaScript, since you can't use HTML, you're not in a web context, you end up writing code that looks a little something like this. So this is React Native code that appears on the left and NativeScript code that appears on the right. So if you think about the challenge here, remember, we're building for all three platforms. React Native and NativeScript are both projects that let you take code that looks something like this and turn them into native iOS or native Android apps. But how do you take this code and actually make it run on the web, to spit out something that can run in a web browser? And I think what makes this conversation particularly interesting is that these two framework options that I'm going to talk about here take sort of different approaches to the same problem. Now, the first option on this list is React Native Web. Now, this is a project it's not something that came out of Facebook. It's actually by a developer named Nicholas Gallagher. He used to work at Twitter. He actually works at Facebook now. And it's something, if you just Google React Native Web, there's a GitHub repo that I'll be showing here in a minute that has sort of the documentation on what you need to get started. And that's the first approach that I'm going to be showing you today. The second one is NativeScript Schematics. Now, the term schematics is actually coming from Angular. So we've been working with the Angular team here at NativeScript to make this approach possible. Schematics is actually an API that's part of the Angular CLI. So the Angular CLI is a command line interface for building, running, doing things with Angular applications. And schematics is their name for essentially their extension or extensibility APIs. So NativeScript Schematics is just saying our extension to the Angular CLI to make it possible to build for these three platforms. Now, the app I'm actually going to build to show you this in action, I've got a simple little Pokemon app. If you know me, you know I'm a fan of the franchise, so a lot of my demos tend to revolve around this. I like to keep my demos simple so that we can focus on how these frameworks are actually attacking the problem and how they're making it possible to build these applications. I do want to say, though, even though the app that we're building today is quite simple, both of these technologies have been used to build very complex things. You saw in the keynote this morning, Todd talked about the portable North Pole app built with NativeScript that runs. It's a couple million downloads around the holiday season. In the React Native approach, React Native Web has, if you look up their showcases, they have the likes of Twitter and a couple other companies using their approach as well. So these aren't necessarily toy projects. They've been used to build very serious things. And to show that, I think the best way to kind of learn how these things work is to actually see these things in action. So I'm going to attempt to demo them here for you today. So what I'm going to do is switch over and make sure everybody can see my screen here and the projector works. I'll crank up the font size. So if at any point you are having trouble seeing something, let me know. I'll do my best to blow things up so you can see in the back. So this is the React Native web approach, which you can find on GitHub. Now, if you go to try this yourself, what I found to be the easiest way to start is there's this Code Sandbox link, which is a way that you can sort of test out a React Native web application in the browser. I found that to be quite easy to use. They do have this other information on getting started. I do have to offer one caveat that the React Native team managed to thankfully break this command for me earlier this week, right before I set this up. So you're going to see me jump through a little bit of a hoop when I go to show my application. But if you could do me a favor, and when you see me manually copying and pasting something, if you could just pretend, just in your head, that I'm doing like something amazing. Like I'm writing some custom bash script, or I've got some like sweet Vim command that you've never seen before. It would really help my own ego as I sort of copy and paste to show you this. So that's one caveat to keep in mind. So here is my actual app. And I'll explain the code here in a second. But first, I'm going to go, and I got to go into my React Native Web folder. I'll bump this up a little bit, too. And each React Native Web project has some npm commands that you can use to run these things. So for example, if I can type here, the command you use to run a React Native Web app is just called start. So I npm run start. It's going to fire this up in my browser, and this is going to be super tiny, but you can see my starting app is really quite impressive. It's just a simple little application that says hi. But I want to talk for a minute about the code that actually is used to generate this. Now, for the code here, and I'll crank this up a little bit too, if you're familiar with React, a lot of this is going to look familiar. This is basically just the vanilla way to create a React component that runs anywhere. And if you're not familiar with React, don't worry too much about the individual syntax. That's not really the point of what I'm trying to show here. The thing that I think is interesting is this part here. So if I was writing a React app for the web, this would probably be something like div span or label or something like that. But instead, I'm using controls that look like this. And these controls are actually coming directly from React Native itself. So at a high level, what the React Native web approach is doing is it's taking that markup that we saw earlier and rendering those as web elements over here. So this text just turns into straight text that appears over here. And I think this is a little bit easier to see as I sort of scaffold this app up. Remember, we're building a little Pokemon viewing application. I'm going to crank this down just for a second and start to build this app up. So the first thing I'm going to do is fetch some data. I've got a little endpoint I wrote to get some of the Pokemon data that I'm going to show in this application. And I'm going to show it with a couple additional UI controls. I've got one there for the list. And I'm going to put another one down here and type it right to show individual list items. And when I say that, the CLI is going to pick up on that change and instantly show my application here. Now, the thing I want to note about this, again, don't get too caught up in the details. I did want to purposely keep this a little bit simple, is, again, it's completely different UI controls. These are, again, coming from React Native. But also notice this fetch method. So for fetch, this is a web API. So I expect this to work on a web browser. But if I take this code, sort of verbatim here, and I'm going to port it over to this React Native app, there's the copy and pasting I was talking about. And I go over and switch over to React Native and npm run this on iOS. This is going to take a second and fire things up on an iOS simulator. And what you'll see when this loads is I'm actually going to be able to use the exact same code to render this application both on the web and on native iOS. And I could fire up an Android device as well. So I should have my iOS simulator. It's actually loading a different version of the app. So let me try this again. Maybe it wasn't totally complete. But in a second, you'll see it runs the exact same version of the code on iOS. And what's interesting about this is what the React Native team has done, and we've actually done the same thing at NativeScript, is implement this fetch method with native iOS and native Android code. which gives you the benefit of writing APIs that you're familiar with, especially if you already know fetch, or we also support XML HTTP request as well. But you get the ability to run your apps in all these places. And it's weird. So the native part of this is failing me, but you'll have to trust me at the moment that it works on iOS as well. So at this point, I have this layout for my web application. Again, it's coming from these sort of cryptic React Native elements. And the next thing I want to do is add a little bit of styling. This doesn't look like the Pokemon app that I showed earlier. So what I'm going to go in and do is add a little bit of styling. Now, CSS, when you're working through this workflow, again, this is CSS. CSS is not a concept that's natively on iOS or Android. So what frameworks like React Native and NativeScript are doing is actually parsing this code and applying essentially the native equivalents. Now, both NativeScript and React Native primarily support Flexbox. That's what you'll see being used for a whole lot of the layouts you build using these controls. And so React Native is actually directly able to take the Flexbox syntax and make it work on the web. So this, again, plays into the code sharing story again, because you're even able to reuse some of the layout components of how you render your elements on the web and versus native applications. The last thing I want to add here is I'm going to go down, and I want to make it so I can actually tap on these items. And so I'm going to paste in a little bit of code. If you know React better than I do, you probably can come up with a cleaner way of doing this. And I now have the ability to sort of select items on the screen. But the last piece of functionality I want to add to this app is a way of actually remembering those selections so that they don't totally go away when the user refreshes the page. And there's a couple different approaches I could take to do this. If you think about the way storage works on the web versus native apps, on the web we have APIs like local storage and session storage and index.db and whatnot. But in the native apps, there's no browser, so those APIs don't exist. But instead, native apps have ways of writing to files, and they have things like SQLite and some other technologies. You can even get into platform-specific stuff, like you could save data to iCloud on iOS or things like that. So when you hit problems like this, when you want to do something differently on the web or native, you have really two different options. So the first thing you can do is you can look for an API or write an API that sort of abstracts those differences away to a common API. And in a way, Fetch is doing this, because Fetch, even though under the hood this is doing something different than what you think on iOS or Android, to you as a developer, you're getting the behavior you expect. You're making an HTTP request on all three of these platforms. And that's the approach I actually want to show. Well, to back up just a second, the other way you can approach this is actually fork your code and do something completely different on the web and do something different on native applications. And for React Native Web, they've got a section on this, in this section called Multi-Platform Apps. And basically, there's two different ways you can do it. There's just a way of doing a simple if check. So if I wanted to fork my code and say, if I'm on the web, I need to do this. If I'm on native applications, I need to do this instead. They also have a naming convention that you'll see we use in NativeScript, or we use something similar in NativeScript as well, where you can create completely different files with different implementations. So if you want to do something radically different for iOS and for the web, that's an approach you can take in putting that functionality in different files. So what I'm going to do, though, is I'm just going to show one API that actually consolidates all three platforms. I'm going to show a little more complex and what I think is a cool approach when I go to NativeScript here in a second. So just to finish this application off so we can move on to the NativeScript one, I'm going to create a little array so I can just store which of these Pokemon have been selected by the user. And when the user actually toggles one of these, I'm going to manipulate that array. I'm either going to push the new entry into the array, or if it's something the user's already selected, I'm going to take it out of there. And finally, I just need a little bit of code that when the data actually comes back from the server, I need to check that data that I've stored locally. And now I have an app where I can do this, and things save. And if my iOS simulator started working, it has the final state of the app. So you'll have to trust me a little bit that that's the exact same code running there for iOS. And I could also take this app and run it for Android as well. And really, this is the promise of this setup, the fact that I'm able to use the same code base to run for all three of these platforms. The key to this, of course, at least with the React Native Web approach, is how they're actually converting these UI elements. And personally, I sort of have mixed feelings about this. Like, part of it is kind of cool, right? Like the fact that I could just take this code verbatim and run it. There are some sort of weird edge cases that I've hit. Now, I'll state that I'm not necessarily an expert in this stack, but there's because this is generated code, you end up with a lot of stuff that looks like this, which part of me gets. Like, I'm I realize this is generated and that I shouldn't be messing with this sort of thing. But the part of me that's a web developer looks at this and goes, ugh. And that if I wanted to, like if I hit some sort of weird edge case, like I hit something with scrolling and I needed to start to configure some JavaScript, and I didn't even know where to start, right? Like just looking at this, it's a little bit of a mess. So at least in my experience, this is kind of cool, especially if you have an existing React Native app, just to be able to toss this in onto the web. But you have to be a little bit careful, and you might have to work around some of these situations when you hit them. The last thing I'll mention before I go on to NativeScript as well is, so in terms of components, and it's back on this main screen here, not all React Native components are supported by React Native Web. They've got a handy little table here that lists these all out here. And you can see some of these are missing. Some of them actually just don't make sense on the web. For instance, the status bar is a good example of this. So on native apps, you can do a lot to configure the status bars. Maybe you want to change its color. Maybe you want to hide it. On the web, you can't do anything with the status bar, right? It's sort of off limits for web developers. And so as such, this is something that if you're using in a React Native app, you'd have to code around when you go to create a React Native web app. So that's React Native at a high level. Hopefully that gives you a brief idea of how that works. What I want to do now, though, is switch over to my preferred option, which is NativeScript, and show just a little different path or a little different approach for tackling the exact same problem. So this is the NativeScript documentation. It's at docs.nativescript.org if you want to check this out for yourself. If you want to check out specifically the code sharing stuff, there's a link down here for code sharing at the bottom of the screen. And if you go into this and you go into the section on creating a new project, you'll find really everything you need to get started. So as I mentioned earlier, NativeScript schematics is built on top of the Angular CLI, so that's one dependency that we have that you need to install. You'll also need to install schematics itself. And from there, the command you need to run is actually just the Angular CLI directly. ng-new just happens to be the command you use with the Angular CLI to create new applications. And then you do have to provide this one extra flag to essentially tell the Angular CLI that NativeScript exists, and it'll essentially let it hook into some of the NativeScript functionality we're going to be showing here in a second. So I've already created that application, and what I'm going to do is take a second to bring some of my things I'm going to need over to this new desktop so we can start working on this NativeScript application. Kill this for a second. So bring the NativeScript app over here, get over my terminal as well, go into the NativeScript app. So I have my NativeScript app here, and what I'm going to do is start by running this. Now, first of all, to run apps on the web with NativeScript schematics, you just use the exact same workflow you'd use for building Angular web apps. So ng-serve, if you're familiar with the Angular CLI, this will be familiar. This is just what you use to build any old web application. And what that's going to do is start up a little web server. And over here, once that starts, I'll be able to view the app. It's quite simple to start. So I'm going to let that run. And in the meantime, I'm also going to start up NativeScript. So I'm going to run this app on Android. And I'm going to pass a new flag that we have coming up. You might have saw it during the keynote to turn on hot module reload. So we'll get a really fast development cycle out of this. So my web app should be up and running here. So I'm going to resize that, give my Android and iOS set up a little bit of time to work. Looks like Android might be up over here. And then I'm also going to run this app on iOS. So we're going to try changing all three of these things at the same time. So Android's firing up there, and I'm going to get iOS running as well. So while that's running, I'm going to actually show you a little bit of the code here. Now, some of this is, if you're familiar with Angular, is going to look very familiar. So this is just sort of your standard Angular structure that you use to build web applications. So you have things like app component, app module, routing. These are just sort of the ways that Angular apps are built regardless of the stack that you're using. What makes this app sort of unique is actually in the component that you'll see here in a second that drives this application. So components are the building blocks of Angular applications, and I have the main one here. Currently, it doesn't do much other than tell me the template and style URL that I want to use to drive this component and actually render it on the screen. So this is almost a difference. This isn't really a difference between NativeScript schematics and React Native. This is actually just a difference between React and Angular. React tends to encourage you to put your CSS and templates right in line, whereas in Angular, typically you put that in a separate template and style URL. So that's exactly the format we're following here. And the interesting part is actually in the naming convention. So you saw a little bit of this when I was talking about React Native Web. But notice how for both my markup and my CSS file that I actually have two different files. I have one for CSS for putting my styling and another .html file for putting my markup. Now, this is really the fundamental difference between these two approaches and why I mentioned earlier how we just simply take different approaches to solving this problem. Whereas with React Native Web, you're taking that exact same React Native code, the exact same components, and rendering them to the web. With NativeScript schematics, instead, we say for your UI, you do fork your code. You have separate markup files. You have separate CSS files. Now, the advantage of this is you maintain full control. You have total control as a developer, especially if you're a web developer that wants to build something very specific. You still have control of how you render these applications. You do have to write a little bit more code, that's for sure. You have to redefine your markup 2 times, but personally, we think the trade-off is worth it. And you also still get to share a ton of the code behind this. So you're defining the UI twice, but as you'll see in a minute here, the component, your services, your routing, all of that still stays exactly the same. So I've got my component here, and I'm going to start, just like with the React Native app, start building this thing up. So I've got a service that I already wrote to get my data. So I'm going to bring that service in, and then I'm going to just go ahead and use this thing. So not that one. I want an S2 to actually bring in my service here. And ng on init is just a little hook that runs when your Angular component actually loads. In this case, I'm just going to call up to my service, get this data, and throw it in an items property. Now, to actually show this, this is where I do have to define my markup 2 different times. So I'm going to go into my list component HTML file. And it's very exciting right now. It says hi. And instead, I'm going to write this little web code. And you'll see that I can crank this down a little bit. I start to see a list appear here. So my service or my component gets the data. My component here, my markup file, is rendering this thing to the web. What I'm going to do next is get over my NativeScript component here. And what I'll do there instead is use some NativeScript UI controls. So again, I'm still leveraging the same code behind the scenes, or the same code to actually in the component to get this data. So that's shared. The services that goes down, that same fetch method is being used to save my data. But I get to define here an optimized setup for showing this application. And it's being weird on Android, but on iOS you see this amazing UI here, which is actually kind of fun. Now, the reason you see this is because there's no CSS in this project yet, right? So these images aren't being resized, and the default iOS behavior here is kind of amusing, actually. But get to see these items in the list. So again, to start to style these applications, with NativeScript, we support Flexbox. We support absolute positioning. We have an implementation of that. Really, it's interesting, because we get this question a lot about which CSS properties don't you support. And they tend to be the ones that are a little bit wonky on the web and that are harder to implement in an iOS and Android context. So think like float. Float is just a weird thing, and it's really hard to make work with iOS and Android components. The other one is display, like display inline, display block. Those are really weird concepts on the web, and so they're really tricky to get working in a performant way on iOS and Android. So I have this here, and I'll again start to put in some code here. So I'm going to style this with a bit of CSS. So we'll do this here. And then you'll see, so my app starts to look a little bit better over there. And then I'm going to put in some CSS here for my NativeScript app. And you'll see my iOS app appears as well. So that was the hot module reload, too, just to show how fast these things change. So if, for example, like I wanted to play with this and just start to play with the image size, you can sort of see just how fast you can sort of iterate on this sort of thing as well. So kind of a cool setup. I will also mention here that even though this is CSS, we also support Sass through NativeScript as well. So if you're the sort of person that likes to use Sass and you have a use case where you want to save some of these variables to sort of increase the amount of code that you're able to share, you're able to do that with this approach as well. So I've got 2 last things to show here. The first is I'm going to add a bit of functionality to allow users to tap items. And I've got a service under the hood that's going to handle this. Now, if you remember earlier when I talked about when you hit situations where you need to fork your code and the options you have, you could try to find an API that's going to work across all 3 platforms, or you can split up your code to provide sort of custom implementations for each of these platforms. So for this service, what I did is I actually did split my code just to show how you might want to approach this. So my service here, first of all, this is the code I'm actually using and have been using to actually grab this data. So again, with NativeScript, we support fetch, we support XML HTTP request, and this is actually an Angular service that's building on top of fetch, and so we support that out of the box as well. But the key part is actually dealing with data, so the same thing I showed earlier with React Native Web. So this time, instead of using some API that abstracts all three, instead I've decided to create a little helper function. So I've just called it Pokemon Helper and threw it in the same folder. And on this helper, I've just created two functions, one called read items and the other one called write items. And in these helpers, first of all, if I show the web implementation of this, the web implementation is nothing more than a little wrapper around local storage. So it's just basically giving me an abstracted API of dealing with local storage. But the NativeScript implementation, I'm using a NativeScript API to hit the device's file system. So I'm actually writing and getting data from a file itself. Now, this is convenient for this example. In a real-world app, this might be far more complex. Maybe you want to use something like SQLite. Maybe you have some sort of more complex persistence way that you're storing your data within your applications. So this is really the approach you would use to fork your code when you hit situations like this. The status bar implementation, the sort of problem around that I talked about earlier. So let's say you want to mess with a status bar in your native application. What you could do is you could create a status bar helper. You could create it for the web that does nothing. It's just a pass-through file since you can't do anything with status bar on the web. But then in your React Native or your NativeScript app, you could then call those APIs in the native context and go ahead and push those things or make the changes that you need specifically for your native application. So that is that. The very last change I was going to show requires my Android app to work. So I was having problems here. I'm going to try one thing here that hopefully gets to work, because the last thing I wanted to show is over here. So even though the apps I've been building today are kind of simple, right? I don't think your next line of business wants a Pokemon checklist app. If they do, let me know if they're hiring. I will stop by. But you probably have, some more real-world requirements or things that you need to build for your applications. And the great thing about taking this approach, this sort of approach where you have the ability to build for all three platforms, is you can still really optimize for those platforms. So for example, remember, these apps you're seeing here, these are native iOS and Android apps. This is the same sort of thing you would build with something like Xcode and Android Studio. So there's a lot of potential in what you could do here. So for example, I'm on the NativeScript marketplace, and this is where we list a lot of our plugins for dealing with different native functionality that you might want to use for your iOS and Android apps. So you could imagine, for example, suppose you're building a login screen for your app. On your web app, you could just build the same login screen you would build today. But on your native app, you could do something like integrate fingerprint authentication or Touch ID or Face ID. We have plugins for all of those things. You could also, if you wanted to use the Facebook SDK for logging in, it's something you could totally import specifically just for your native application and provide users with an optimized experience when they're on the native app. There's other things as well. If you're building a mapping app, maybe you want to build in a native mapping SDK, really make the maps feel a lot nicer within your application. Like I said, if I get rid of the filter here, there's quite literally about 1,000 of these things that you might want to do. Geolocation, camera. With NativeScript, the raw iOS and Android APIs are also available. So there's really no limits to what you can do to customize your apps to build the best possible experience. So let's see. Oh, so good. My Android app is working. So luckily for you, I have another very not practical demo to show you to wrap this up. It just feels like a fitting way to end it. So what I'm going to do is I got to go back to my main list component here. And in this component, I'm just going to wipe this out and do something completely different. So I'm going to be using the NativeScript audio plugin. This is a great plugin that's maintained by NStudio, one of our sponsors out there. So thanks for putting this available. It lets you do things like not only play audio, but you can record audio. You can do loops. Remember, you're in a native app, so there's a lot more potential. You can integrate with a sort of native audio system on iOS or Android devices, so you can integrate directly with that. So pretty cool. That plugin is practical. This one probably isn't, but it doesn't make it not fun. This is the NativeScript Explosion plugin. Because the internet is a magical place, someone wrote an Android SDK for just making things explode. And one of the people at NStudio actually decided, well, that needs to be a NativeScript plugin, which I wholeheartedly agreed with. And then somebody else went through, because the open source community is amazing, and added TypeScript definitions to this too. So we now have a fully complete Explosion experience. And I could, and what I decided to do, because I love building practical apps, is, instead of actually toggling the selected Pokemon, Let's instead just make them explode, because I have a native app, and I can make them explode. So why wouldn't I do this, right? And of course, I have to have a fun little sound effect to accompany this, too. So when I change this, oh, good. So HMR is working. I get to see my change right away. And now, I think I got to get my mic a little bit closer. But now when I select, I don't toggle. Oh, let me see. No, hold on. Without the sound, it's not the true experience. So give me a second here. Here we go. So when you go back to work and your boss asks you, what sort of techniques did you learn that you're going to apply to our next line of business production application? Now you have your answer. OK, so that's more or less. Let's wrap this up here. So that's the demo. Hopefully, on a serious note, hopefully you think that's as cool as I did. I mean, keep in mind what we're doing here, right? That was a native iOS app, a native Android app, and a native web app, or well, just a regular web app, right? And I was building that all from one code base, right? I had the ability to fork my code where it's necessary, to still do optimized things on these applications. But think of how much I'm sharing. I'm building the same language to build all three of these apps. Normally, I'd have to go into places like Xcode and Android Studio and deal with these other technologies. I'm also using the same framework. Regardless of whether I prefer React or Angular, I'm still consolidating on one framework for this entire application development. So if you're interested in getting started with this, if you just Google React Native Web, that GitHub repo really is the best place to go, just in terms of laying out all the things that we talked about. For NativeScript, if you go to docs.nativescript.org, again, that link for code sharing on the bottom is what you want to do. It's going to have the next steps you need to get started. I should also mention that we talked pretty much exclusively about building new applications, but for NativeScript schematics, we also have a way of migrating existing web apps that you might have built on top of the Angular CLI. So if you have an Angular CLI app in production, you can still install schematics, and there's a migration path where you can start to migrate your components over and start to build a native app for a web app that you already have. So that's also a link in that code sharing section. And lastly, so the last question I get quite a bit is, which of these approaches do you want to use? And obviously, I have my own biases and opinions in this sort of question. I think some of it is just at a framework level. If you are a React person or you're more familiar with React, you're certainly going to feel more comfortable working in a React environment. The same is true with NativeScript and Angular as well. If you are an Angular developer and you're comfortable working with Angular, you're going to feel more at home working in that environment as well. I think the more interesting question is which approach is better in terms of should you actually generate a web app from components that you're writing that are intended for a sort of a native framework, or whether it's better to actually fork your code and put developers in control of creating optimized experiences for each of these environments. And for this, I don't necessarily have a good answer. I actually can see serious pros and cons of both. I appreciate the code savings I get from just generating my web application, and especially if I'm writing something quick or dirty, I think that's actually kind of cool and kind of nice. But for something more complex, I tend to lean towards more forking my code and just sort of having the ability to really create what I want. But I have this slide up here because I'm actually curious what you think. So I'm going to be at this event for the entire time. Actually, if you're a NativeScript team member, can you raise your hand? I know some of you are in this room. So there's 4 or 5 around here. There's also a NativeScript booth here. If you have opinions on this, if you saw this code sharing thing and you think this is great, or maybe this would be great if only it did this, or I prefer doing this, come chat with us. We're all at this event, and we'd love to talk to you about this. And that's it. Thanks.